Okay, in this video, let's talk about section 9.3, the law of cosines. Okay, so let's see. Assume we have a triangle. Let's assume we have an acute triangle. All three angles are acute. So we're going to place acute triangle in this way. We place one side along the positive x-axis, and that's this side we call the B, and then we get the third point above x-axis. So this is a point, this is angle B, and this origin is C. This vertex is A. This is angle A, angle C. Okay, A, B, C, and this is A, and this is C. Okay, so we just place a triangle, a acute triangle like this. Now let's see. We want to get the coordinates of this point. What is the coordinate? The coordinate is x and y. So x, what's x? X, this is x. X coordinate, the horizontal direction. So x is the adjacent side of angle C. So x over hypotenuse, this time A is hypotenuse. X over hypotenuse is cosine C. Y, what is a y? This is a y. Y is its height, right? Y is a height. So y over hypotenuse is sine of C by the definition of a sine cosine in the right triangle. And from here we get x equal to A cosine of C, y is equal to A sine of C. So this point, it has x coordinate A cosine of C, y coordinate A sine of C. Okay, very good. And the other one, this part, this point is on the x-axis. The length is B, so it is B0. So the point on the x-axis is B0. This point is A cosine C, A sine C. So you get two endpoints of the segment. Then the length of the segment is C, right? We know it is C. So the length of segment C is square root of stuff. C is square root of A minus A. Now x coordinate minus x coordinate plus y coordinate minus y coordinate square, and then take square root, right? So this is distance formula. You have 2 points, and the length or the distance between those 2 points is the length of the segment is measured by this. We square two sides. We don't like square root. Square root is hard to compute. So we square two sides. We get a c square is equal to a cosine c minus b square plus a sine c minus 0. It's just a sine c square. Let's simplify it. Simplify it. This is a square cosine c square minus 2ab cosine of c plus b square. This expansion is the first square. And second square is just a square sine c square. Okay? And then you see here the first term, a square sine c square, a square cosine c square, a square sine c square. We factor out a square, we get cosine of a c square plus sine of c square. That's the first and last term. And I copy this b square and minus 2ab cosine c. I exchange the position of those two terms. Cosine square plus sine square is 1. So we have a square plus b square minus 2ab cosine of c. And this is c square, right? C square is equal to this. So I copy c square here. And this is called the law of cosine. The law of cosine is that c square is equal to a square plus b square minus 2ab times cosine c. here this is angle C. This is the length of the side facing C, opposite angle C. All right? So this is one of those laws. There are three equivalent ones, three parallel ones, not equivalent, three parallel ones. So here you choose a C as the opposite angle, then you get a C, this one. If you choose A as the opposite angle, you will have B squared plus C squared minus 2BC cosine A. It's permutative. And you have the other one, B squared. B squared, you see, B corresponds to cosine B. And you already have B, then you have A and C for the rest of the part. So there are three laws of cosines, 1, 2, and 3. The proof is exactly the same thing, you just measure the distance. Okay? So there's no weird thing to prove. All right, so keep this in mind, the law of cosine, the law of cosine. Let's do some exercise. First, let's solve SAS. You see here, what is AB and angle C? A is one side, B is the other side of the angle C. So you have side, angle, side. So this theorem is a perfect theorem for the SAS triangles. So solve SAS triangles. A, B, cosine C, right? Okay, so let's see. Solve the triangle A is equal to 2, B is equal to 3, the angle C is 60 degrees. Okay, let's check. This is 2, this is 3, this is 60 degrees. You connect these two endpoints. Very good. So what do we need? We need to use the cosine law of cosine to determine the opposite. This is A, this is B, so the third missing side is a C. So we get C squared is equal to A squared plus B squared minus 2AB cosine 60 degrees. Okay, so A is 2, 2 squared is 4, B is 3, 3 squared is 9, minus 2 times 2 times the 3, cosine 60 degree. Cosine 60 degree is 1/2. Okay, so this is a 13 minus 2 canceled, 2 and 1/2 they cancel, so 2 times 3 is 6. 13 minus 6 is a 7. So C squared is a 7, so C is square root of 7. Okay, so to solve a triangle, you need to figure out all the sides plus angles. So you already have two sides. This is the third missing side. Here you only have one angle. Let's talk about other angles. To figure out other angles, what do you need? You need this. Let's practice the law of cosine. Law of cosine. So you need this law of cosine. How do we do it? We change the side. So this time we use C as a side on the left side. Okay, if we want to compute A, you are going to put side A on the left hand side. Side A is B squared plus C squared minus 2BC cosine A. Side A. All right. So A is what? A is 2, so it's a 4. 2 squared is 4. B is 3, square is 9. C is square root of 7, so square root of 7 square is 7 minus 2B and C cosine of A. 2BC cosine of A. Okay, so let's check. So move this term to the left side, 4 to the right side. So we'll get 6 square root of 7 cosine of A is equal to 9 plus 7 is 16 minus 4 is 12. So 6 square root of 7 cosine A is 12. So cosine of A is 12 over 6 times square root of 7. Cancel. You get 2 over square root of 7. Cosine A is 2 over square root of 7. A is cosine inverse of 2 over square root of 2 over square root of 7. Cosine inverse 2 over square root of 7. In the exam, leave this as your answer. Don't simplify it. Don't write the angle, because without a calculator you cannot find the angle. Okay, so you get this angle. You get the 60 degrees. Remember, angle A plus angle B plus angle C is 180 degrees. So you put A as this number, C as a 60. So B is 180 minus 60 degrees and minus cosine inverse of 2 over square root of 7. So it's 120 degrees minus cosine inverse of 2 over square root of 7. And that's it. That is the answer. All right? So here, leave it like this. Don't simplify it. Okay, so this part we use cosine. We, of course, can also use the sine, the law of sine. So I'm going to do one thing. The law of sine, what is the law of sine? So it's a sine A over A is sine B over B is sine C over C. So we know ABC. So it's a sine A over A is 2. Sine B, I don't know. B is a 3. Sine C, where is it? C is a, okay, sine 60 degrees over C is the square root of 7. Okay, so for example, from here, we can figure out sine B is equal to 3 over square root of 7 sine 60 degrees. It's a positive number, so B is sine inverse of it. But when you do this problem, there's a minor thing we have to be careful. This process is not accepted all the time. The reason is that sine B is a positive number. Then B could be either one angle or pi minus it. So remember that sine B is 1/2. Then B can be 30 degrees or 5 pi over 6, 150 degrees. So there are two solutions. This place, you need an additional discussion to tell us why this is accepted, not the other one. Okay? So this is a reason when we try to solve SAS problems, we don't use the sine, the law of sine. The law of sine has some problem because from here to here, I don't know if it's a acute angle or not. Okay, so this method, it may work or may not work. It totally depends on the quantities. Sometimes we can use the quantity, the values to determine it, and sometimes we cannot. So for the SAS problem, try to use the law of cosine, not use law of sine. It gave us a lot of trouble to determine if we have this angle or we have the other angle. So that's a serious problem, okay? So this is a totally correct one. And here it's not accepted. If you directly get this, I don't know why you get this one, not the other angle. One angle is acute, the other angle is definitely obtuse. You have to know if it is obtuse or not. All right? So for the cosine, it doesn't matter. Cosine, you see the angle A is between 0 and pi. The angle A is between 0 and 180 degrees. So the range of cosine inverse is exactly from 0 to 180 degrees. This is a 1-to-1 function over this range. So you can just directly apply cosine inverse. So that's the reason we prefer the cosine inverse, not the sine, the law of sine. This is not working. I'm trying to emphasize for the SAS problem, if you want to find the other two angles, you must use the law of cosine. Okay? Let's do one more. Solve another one. Let's solve S triangle, which means we know all three sides. We want to find all three angles. So solve the triangle. A is a 4, B is a 3, C is a 6. Okay, so we will start from each the law of cosine. For example, if I put a square on the left side, the right side, it will be b squared plus c squared minus 2bc cosine of angle A. So A is a 4, square is 16. B the 3, square is 9. C the 6, square is 36. Times minus 2 times B times C and cosine of A. All right, so let's do the movement. So 2 times 3, 6. 6 times 6, 36. Cosine of A is equal to 9 plus 30 is it's 29. 9 plus 36 is 45. 45 minus 16 is 29. Okay, so we get cosine of A equal to 29 over 36. So A is cosine inverse of 29 over 36. All right. Let's see another one. This part we get A. Let's look for the side B. So B, not side B, angle B. Then you put B, side B on the left side. So it's A squared plus C squared minus 2AC cosine angle B. Whenever you put a side on the left hand side, the angle will be its corresponding angle. So B is 3, square is 9, A squared 16, C squared 36 minus 2 times 4 times 6 cosine of B. So we get 2 times 4, 8, 8 times 6, 48. Cosine B is equal to, this is 52, 52 minus 4, 43. 52 minus, okay. So cosine of B is 43 over 48. 43 over 48. Then B is cosine inverse 43 over 48. So this is a second angle. You get the first angle, you get second angle. Of course, you can repeat this law of cosine to get the third angle, but we know that the sum of three angles is 180 degrees. So C is going to be 180 minus first angle minus second angle. And that's it. Don't simplify it during the exam. Outside the exam, of course, you can use calculator to get the idea, to get the value. But during the exam, don't simplify it. Okay. Three. We solve some applied problem. Okay, so let's see the problem example. A motorized sailboat leaves Naples, Florida, bound for Key West. A 150 miles away, maintaining a constant speed of 15 miles per hour, but encountering heavy crosswind and strong current. The crew finds after 4 hours that the sailboat is off course by 20 degrees. Okay. Question A. How far is the sailboat from Key West at this moment, at this time? Okay, now let's see. So there's a one place, a city, Naples. There's a Key West. If there's no crosswind and the current, then this trip will be straightforward from Naples to Key West. But with certain crosswind and the strong current, so there's a 20 degrees angles. So this is 20 degrees. Okay, and for the boat, it doesn't care about the direction. The speed is a constant. Speed is what is speed? 15 miles per hour. So it's a 15 miles per hour, and the boat goes 4 hours. After 4 hours, so this is 4 hours. 4 hours, the sailboat. The sailboat goes 15 times 4, 60 miles after 4 hours, right? So it is here. And we know that between the Naples and the Key West, it's 150 miles. It's 150 miles. So the question is to ask, at this moment, after 4 hours, what's the distance between the boat and the Key West? So this is exactly the opposite side with respect to the angle 20 degrees. So let's call this side C. Then C squared is exactly the one side square. This is 60. 60 square plus the other side, 150 square, not degree, square. And minus 2 times 60 times 150 and times cosine 20 degrees. See, this is a way to set up the equation because you are looking for the opposite side with respect to the angle 20. You compute this, you will get C is, okay, so you just compute this quantity, or you don't compute because you have cosine 20 during the exam. So at least you have to figure out what is a 60 squared, 3,600. 150 squared is 22,500, and minus 2 times 60 times 150, so 18000, and times cosine 20s. Yes, and then so C is equal to square root. This number is 26100 minus 18,000 cosine 20 degrees and take square root. This is a distance. This is a distance right after 4 hours. Okay? So through second question. Through what angle should the sailboat turn to correct its course? Okay, so remember at this moment it's heading this way. It's heading this direction. So you have to do what? You have to turn. See, you have to make a turn from this way to this way, right? From here to this in order to go to the Key West. Okay, so let's call this as a theta. For this theta, it's not in the triangle, it's outside the triangle. So here's the theta, then this place is pi minus theta. So if we can know the internal angle and we know the external angle. Okay, so this is 150, 60, and this C. So we can determine the angle pi minus theta. So let's check. So we get 150 square is equal to 60 square plus C square, and minus 260 times C times cosine pi minus theta. Cosine pi minus theta. Cosine pi minus theta is equal to negative cosine theta. You can use that some difference formula to check it. It is equal to negative cosine theta. So it's not degree, square. 60 square plus C square. And this is a minus. There's a minus sign. Cancel with this minus sign. It's plus 2 times 60, 120 C, and times cosine theta. And from here, we can determine cosine of theta is 60 square plus C square minus the other way. 150 square minus 60 square minus C square over 120 times C. You just move these two terms to the left. Okay, C is here. I'm not going to copy this long quantity, just make it happen this place. And cosine theta is this number, so theta is going to be the cosine inverse of the whole thing. Okay, so when you get the theta, you will say it rotate or turn the direction. Okay, turn the direction what angles to face the to head to key west. Okay, and C is how much time has been added to the trip because of this. Well, what is the question of this? So you see here, originally, if there's no strong current and the crosswind, you go straight forward. So originally, you only need 150 miles over 15 miles per hour. So you need 10 hours to go to the Key West. But currently, you have the long tour, 60 plus a C. So 60 plus C, this is a total distance over 15 miles per hour. And this ratio gives you the time, the new time. This is our original time. You use the new time to subtract the original time. It is a time you need to add it. So this quantity will be the answer. Because we don't have a calculator, I'm not going to compute it. Okay? So in the exam, if you have some problems, you will write it in abstract symbol. You will not use calculate to compute it or to simplify it. It's not required. You can never use calculate in a calculus class. Okay, so this is the section 9.3. In the section 9.3, you learned 3 formulas. You learn those 3 formulas. The law of cosines. The law of cosines is a perfect design for the SAS and SSS problems. Okay, so make sure you understand how to do those problems. Okay, we finish this video and we will start another video with another topic. Thank you.